Yeah, and I'm very excited to be giving a keynote. Maybe not the most traditional keynote format, but yeah, let's see how it will go. So first, something about myself. Yeah, it's kind of untraditional, but I studied sociology. During my master's, I got really into programming, and I started with R, but quickly changed to Python. And yeah, so I'm really in the field of data analytics and yeah, analysis. I'm also an Intel AI innovator, which means I get access to their latest technologies, and I get to experiment with things, give talks, and yeah, it's a really nice opportunity. I really love open source. I love innovation. I love working with the latest, newest things. And I have a fascination with human-machine interaction. So what do I do during the during the week? I'm a lead data scientist at Jibes. It's a company in the Netherlands. They're expanding internationally. There's about 35 data scientists. I'm working there for 4 years by now, and I've worked at 15 organizations by now. And what I do mostly is work on blockchain, social robots, like the picture you can see here. Natural language processing is what we mostly do. So that means like unstructured data instead of the tables that we're usually used to. Then machine learning, deep learning, and also computer vision. And recently I gave a talk about when to use machine learning at EuroPython. So yeah, I'm traveling the Python conferences. So yeah, something about what I've done in open source. Yeah, these are my kind of some of my projects. I also have a blog, but I don't frequently post there. But yeah, maybe if you want some inspiration, you can find some here. My most notable project is using the Wi-Fi signal in the computer to predict where it is. So yeah, go check it out. There's some fun projects there. So actually, I also wanted to tell you, like next week, I'm going to do another talk, and it's going to be on a neural network that learns to like kind of act as if it's a company. So you would train it on a Twitter stream of like customers saying something, then an employee answers, and this neural network will then automatically learn like an answer given a new question. So it's a pretty fun project, and it's going to be at the O'Reilly Artificial Intelligence Conference. I'm pretty excited about it as well. But yeah, just more ideas of what I'm doing. Also, I'm not sure how readable this is, but it's still a fascinating picture to me. It's about the Gartner hype cycle. They're trying to predict what will be like the trending things, and if they're like being hyped up, if they're kind of crashing, and yeah, they've been doing that since 1995, and it really fascinates me to see what's on there. In those days, object-oriented design was a disruptive technology, so it's quite fun these days to see those old things, but also to have an idea of what could come or what is out there. And well, the arrows show the things that I've done some project with or some experimentation with. Yeah, so it's if you look for inspiration to do something with a new project, that's also a good source, you know. But yeah, here today. First, I want to give a bit of a background for this talk, like why is this interesting to more people than they would think, just going by the title. I will explain something about like cryptocurrency. I will be talking about high-frequency trading, and I'll also be talking about Asyncio. That should be more familiar in the just simply Python ecosystem. Yeah, so actually more history on me again for the background of this talk. I was doing a lot of AI competitions, just mostly because, yeah, there are fun games out there. So on the images here, you can see the like a poker game, and the idea is that you you write a bot, right? You write a program that then battles other bots, and that's like a competition. And I always learn a lot on these kind of challenges, like on new algorithms, on like tricks, on just simply programming. The other one is that you can see is Risk. It's a very complex game for a computer actually, and yeah, it's a lot of fun. But yeah, so I'm the one who really enjoys meta games, so like that means talking about what could have happened or what what strategy you could have done, maybe even more than playing itself. I like to discuss games, so that's well, it helps when talking about cryptocurrency trading. It's a thing. Well, yeah, the thing with these competitions is always you have a really clear score, right? Like you win or you lose. And well, with cryptocurrency, the ultimate measure is, do you win money or not? So yeah, that's the kind of also a kind of a natural measurement, but more in the real world, you could say, with real world consequences compared to like these kind of board games. That's kind of what draw me to cryptocurrency trading. And yeah, I guess this is not really readable, but yeah, this this is like another example of. But I guess it really doesn't make sense if you cannot read it. But yeah, you can see here 4 bots, and they have to make at each step of this game. They have to make a decision: do they go left, right, up, down? And yeah, sometimes you can. That's kind of the point of this slide. Sometimes you can have a very simple strategy that is going to be very effective. So in this case, I only wrote 75 lines or something in Python, and that already got top 5%. So yeah, I really like this aspect of coming up with a human strategy, making that into that the computer can execute it for you. So using the benefits of human strategy plus computers, for me, yeah, very interesting combination. But yeah, but even I also never thought I would be crypto trading. So let's get that straight. Like I've been working on blockchain, but yeah, I never thought I would be crypto trading. So that's an important point. Obviously, cryptocurrencies are relatively new, so it's not like you can be a young. As a young person, it's like, yeah, I want to be a crypto trader or anything. But yeah, I hope that there's already a little bit of an idea why it's interesting. I also considered trading at some point. I mean, I am a data scientist, so like, what are interesting data sets? Well, that's for sure. Stock data is interesting data, but I always considered it a bad idea to do it. Because well, you would need really big machines to be like competitive, right? Like with these kind of institutionals, with billions of, like it's very difficult to be competitive, because they have the short cables to the exchange. So like you have a building where the trading happens, and they sit in the next building just to have the fastest way to have the deals. Also, the commission is very high with the traditional trading. So if you want to, like, that always was also for sure, like, yeah, if you have to pay so much to be even be allowed to trade, then it's impossible to make a profit, right? And what you'll also see is that the data involved with trading can be very expensive. Even what you would think is like rather basic data can be very expensive. So like that's the idea of traditional trading. That doesn't make much sense. But yeah, some of these points are not necessarily true for cryptocurrency. So, well, let's go to what are cryptocurrency actually. So it starts with the idea of e-currency. So the currency we have now are regulated by by governments, and well, also banks in a way, right? So the idea of e-currency was that they've been looking for years for a way that yeah, you can have like more of a like global currency, because yeah, there's still, you may not notice it that much, but it's difficult to make transactions across borders. So the idea is, of course, with has been like, how can we have like yeah, currencies? Then blockchain happened, and well, blockchain is difficult to explain actually. Like people say that the first 10 times you think you understand blockchain, you still don't understand it. But my simplest explanation is you cannot trust the system administrator with money. So the idea is that as long as you have a centralized system, there's always going to be one person who can make changes into the system to say, okay, now suddenly I have 1 million extra. The idea with decentralization and what blockchain helps with is that there's not one single person that can influence the system. That's a simple, important part. Well, blockchain really took off, and a lot of yeah, like cryptocurrencies came from this. So Bitcoin is the most known one, I guess. I don't know who knows Bitcoin, heard of it, or go on hands. Yeah. Yeah. So yeah, it's the most popular one. At one moment, one Bitcoin was worth $20,000. It really goes with hypes. But yeah, well, the interesting thing about Bitcoin is indeed it's global, right? So even when companies are banning it, it would still be possible actually to trade. But of course, you're doing something illegal. But so actually, I've been working on blockchain applications for banks and insurance since 2016, and in those days, yeah, I mean, it's interesting technology, but I never thought that it would be like blow up so much. Actually, it's a really unregulated field, and yeah, I actually got a few ethers, which is another currency. For giving some machine learning lessons online, just like a donation. And the thing is that I actually lost them. And yeah, that's the kind of a thing. Like once you lose something, there even like I can explain the situation. There was a front end in which I wanted to make a transaction, and you know those placeholder fields in forms where it looks like you filled something in, or an example of what you should fill in. Well, where I wanted to transfer money to looked like it already been filled by the example, like a grayed out value. So I thought, okay, send, and that's the moment where they didn't catch the on the front end part, they didn't do any input validation, and so it was sent to the 0 address. And so, well, after it got really, really the value got up. At one moment, it was the value of what I had would have been $30,000. The moment at that time, I couldn't help but go to a Reddit to ask this question, like, guys, is there anything I can do at this point? Because it was already, yeah, a lot later. But it would have been really cool if it's possible, but yeah, it's not possible due to the implementation. But yeah, it gets a lot of votes, such a question. It's a kind of funny thing that in unregulated field, you know, I contacted the owner of the website, and he's like, yeah, well, sorry, you know, like it's of course not his responsibility. So, but yeah, it's fun things can happen. By the way, at the time it was only $150, so at that time it's it's not that shocking. But yeah, it just also shows how much it can increase in time. And well, to give more of an idea of cryptocurrency, there's around 2,000 of them by now. So it's there's really a lot of them, and some are related to each other. Some are based on others, well. what is the game then in the end is like, well, of course you want to buy when the prices are low and you want to sell it when it's high, right? It's very obvious, but yeah, that's easier said than done. So the way it works is, how can you buy these is through exchanges. So it's pretty much, there's multiple exchanges in a lot of different countries where they will say, you know, we sell these for dollars or euros or, yeah, you can then buy an amount of one currency and it will be on that exchange. Note that this is like not anymore, when you're trading on an exchange, it actually doesn't have anything to do anymore with blockchain, but that's interesting detail. But yeah, so there's multiple exchanges, and that's just companies that allow you to trade on these currencies. And the cool thing is that they all have APIs. So this makes it that you can completely automate the process on trading easily as a person who's not belonging to an institution, but just someone for fun who likes to program. So yeah, well, the funny thing is actually with these currencies is that some look so much like another that it's pretty much, they took Bitcoin, the Bitcoin code, it's on GitHub, they cloned it, they changed a few variables, they make a new website, they have some big story about how this is going to be the new coin. And then a lot of people are buying it, and it becomes worth millions, and they're all laughing. But it's really ridiculous how this kind of unregulated field, marketing and everything comes together, where you're really just able to just clone some, like it has happened. I think Bitcoin Gold or Bitcoin Cash or like everything is cloned, and there's very few new ideas, but I mean, the technology of blockchain is very interesting, and there are still good projects out there that are really trying to do the innovation there. But on the other hand, there's also a lot of coins that, yeah, they're not really doing much innovation. I'm not sure how visible it is on the slide, but what you can see is like how much percent the coins change in value over the last 24 hours. I don't know if it's visible, but some of the green ones here show 15% plus, and some of the other ones show minus 5% or something. Well, in traditional trading, if you're successful, if you would have 7% profit per year, and here on a daily basis, there's so much variation. It's really crazy. So if you have something that would work in this field, that can be very lucrative. But yeah, so let's go to 3 possible ways of trading. So like, let's talk about strategies that exist in trading and can also be applied in cryptocurrency. So the first school is the fundamental analysis, and it basically says that, you know, a currency or like some like stock or something has like an intrinsic value, and they're trying to say, you know, like if the market price that I can now buy it at is lower than what we think it's actually worth, right? Due to all these kind of financial information about companies, or, you know, like they're really trying to do like a fundamental analysis. And then they would say, you know, it's a good idea to buy this because eventually it will go up, right? It's undervalued, so we should buy it. That's kind of fundamental trading. Then, and that's also a very popular one, is the technical trading, technical analysis, which is basically saying is all that you need is to know the best price or of a lot of coins, for example, or just a single coin, and all the information is you can find in the historic price. So you can see kind of like up, down, and they would say it's possible. Like I have also an image for it. Not sure again how readable it is, but there's like one circled where a pattern is called, it's called a hammer. And they have so many like ways of, like, you know, if a price goes like this and like that, or like if it is like all these kind of drawings they make to say, you know, it's definitely going to go up or it's definitely going to go down. And yeah, it's also an interesting way of thinking. Of course, there's a combination of the two. But I just wanted to point out another one that's done a lot. Well, there's a lot of coins, there's a lot of exchanges, and this is kind of what makes like a market in trading like more stable, is when there's the arbitrage. That means at one moment you could buy, for example, one Bitcoin for $6,000 and at the other one at 5,800. Then if you would buy it at the second exchange and you would get it to the other exchange, and you could sell it for a profit. So this is arbitrage. I know some people that were doing it. And I also know someone who was doing it at a time where just all the prices went up. So he made some silly bot, but just because the prices went up, he earned a lot of money on it. Not particularly by doing this, but at least the field or these tools or strategies are used a lot in trading. But yeah, actually, I want to bring a fourth, which in the end, everything can be integrated. It's not, but there's also the idea of event-driven. What I've seen is that even something like a tweet could increase price, right? So it's not just based on historic prices or fundamental information. Maybe it can also be on the hype of people looking on Twitter and like that. Well, this is an example of a price, and I guess you can understand where I'm going with this, saying that events can also have influence. This is what was the event that caused it. So it was the coin called IOTA, and this was posted on news, like Microsoft and IOTA are going to work together basically. And this increased the price by 4 times. So you might it's very simple. You had $1,000. It's now $4,000 in like a matter of a few days. That's what event-based could potentially do. So let's, this was on Reddit. It got really a lot upvoted as well. Well, if you look here, the moment that this article came out, before it was posted on Reddit, before it was posted everywhere, the price was $1.25, and you can see at the peak it was like 4 times more. So I think something like 550. So that was in a matter of a few days. But then what happened was that there was another Reddit post a few days later, and there seems to be no Microsoft press release. So it was what we call fake news. Someone tried to boost the price of the currency in the end, or people fell for it in a way, and you can see what happens to the price. Interestingly, if you could predict both, then that would be, of course, the best. But well, what was next? So back to how did I get started on this? As a data scientist, I always like to find like a very simple. I try to find a simple solution. It's also trendy to do a lot of machine learning, but I thought, maybe it can be just very simple. And so what I was doing was, I just analyzed the price data to see what kind of tweets or posts were happening before price increase, if there's any kind of pattern there. And initially what I did was that I created a wrapper around one of the exchanges, so that when one of the keywords would be mentioned, I would send myself a link that when I click on the buy button in the email, it's going to go all in with the money that I have. So yeah, it's I mean, that's just fun programming to me, you know, like most of all, it's just fun to make these kind of things. So I had like the buy endpoint, you know, like in this case it would be okay, buy IOTA for Bitcoin, just yeah, go all in. Similarly, you would have like a sell way that you just yeah, get it back, right? In the best possible case, you would go to here, you would buy it before it goes up, and you would sell it when it's high. That would be the ideal case. And then I also made a Slack bot because yeah. Turns out actually that I myself can be slow before I would see the like. So you have to be sometimes really fast, and yeah. So I made a Slack bot, also a fun thing. You know, you can ask things like, okay, what is the price? Or yeah, it's fun to make a Slack bot. I don't know if anyone did it, but it's pretty easy and fun. So I also let some friends look at it. You know, see if yeah, it's just a fun thing to look at. But the thing was that we would always still be too slow. Like, obviously, if bots are also out there, then they're going to be a lot faster than if I see the message an hour or sometimes only 10 minutes later or something. You could be too late for this. So then I thought, yeah, well, I have to try to make this completely automated, which really kind of frightened me in a way, because yeah, if you make a mistake, yeah, it can have pretty bad consequences. But yeah, that's the way to go. Yeah, so I never thought I would be. I never thought I would be trading, but I also never thought I would go into high frequency trading. But yeah, this started to look like it. So the idea was actually, my strategy here was, once we find a signal, determine a good price. Yeah, buy and then later sell. So what I did do was do kind of simulations with this. So like you have historic data and you can simulate kind of like what would have happened if I would have bought at this time. How long should I hold this and sell it? So I tried to come up with the simplest strategy. Hold, for example, for 10 minutes and then just sell it off. Well, in the end, what is the thing that it really, yeah, depends on is, or what is the thing that you're going to send to an exchange is like, I want to make a new order, and you give it some parameters like, yeah, I want to buy Bitcoin for dollars. How many of those you want, and at which price. And there's still some strategy involved in the options, because you have type limit, which says, okay, at most for this price I'm willing to buy. When you say type market, you say, you know, at any price currently, just give me how much I can get for the currency. And that's how I started. And I can tell you already that's not really a good idea. But another one is you can see time in force. Here's it immediate or cancel. That means either I get it at a specified price, I can fill my whole order, or cancel. And there's like a couple of things which really have an influence on the kind of strategy you want to make. And well, these are the kind of things. All of this stuff is like involved in the strategy of this game. Well, so. In the end, once I found something that I thought, you know, yeah, this could work, then I wanted to be the fastest one to respond, because I noticed others are also responding on these kind of events. So, for example, if you see like the Microsoft working together with IOTA, like pretty much any coin working with Microsoft, I can guarantee you that the price would go up. Of course, it has to be the first one, because if it's really retweeted and read it in like a couple of days, then you're too late. But if you're the first one to get it, you can count on the fact that it will go up. This is no trading advice, but yeah, just some observation. Yeah, so actually in the end, I got it down to 0.7 milliseconds from the moment that I have an event to actually making an order. And I wanted to tell you something about what I did there. And yeah, I think it's a really fun thing, you know, because at this point it's just an engineering problem, and that's also fun, like just programming. Well, because some things can go wrong as well with this, I got really enthusiastic about making sure that I have full insight into what's actually happening. So I was sending myself notifications by phone, email, and Slack at varying times. Get the push notification was a bit faster than if I would get it through email. I mean, you want to always know what's going on. I use Sentry. I don't know if anyone knows Sentry here. I see quite some people. I was very happy with Sentry as a way, because I don't use one machine. I use multiple, and it is a really nice way. I also used Quart. I guess everyone knows kind of Flask, or most people, like web framework. You have Quart, which works for async, which was for me just a way to inspect the state, or the kind of, is everything still working as planned. And I also used an external process, a health check, which then was constantly every couple of seconds asking the state for some values. And for example, I was monitoring some websites, and if I see that the last time that I didn't get it was longer than 10 seconds or something, then it should send me a notification like something is probably wrong. Actually, I have like this kind of one error is not an error; it has to happen 2 times or something. Like all this kind of logic to make you feel comfortable that things are working. And as I was mostly doing innovation, less production kind of things, this was really, really important for me. So I can also really advise to in that regard to do something like this, because when your own money is on the line, like this much, then this really helps you look for how can I make sure the integrity is good for something like that. Other than just checking if URLs are visited, is the process itself alive? And of course you want to be notified. Another thing, or another couple of things. So for my case, the most important part was internet speed. And I didn't need to do much complicated analysis. If it's a bunch of if else to figure out if I want to make a trade or not. So CPU is not going to make much difference, and it pretty much didn't need memory or disk or whatever. So who cares about RAM and CPU for once? The thing was, I was interested in a lot of different things of information, but what I realized soon was that it matters in which region you are, and it matters which cloud provider you use. So I was happy with Google, and it has really fast internet. A lot of regions were there. But the interesting thing is that they give you, on the cheapest plan, they give you 20% of a CPU, which I thought, I don't care about CPU, that doesn't matter. So that should be good. But then when I looked in the observation of how that actually works, is that it just means that they will pause you. So the amount of work that I have to do is very simple for a CPU. But what they basically do is, okay, you now get to run 0.2 seconds, then you sleep for 0.8 seconds, and then you get 0.2. So imagine wanting to be fast, how, that it's just very unpredictable like that. So that was similar with DigitalOcean, similar with AWS. Also tried a dedicated machine, which actually just had worse internet for me. In the end, I settled on Linode. I'm not sponsoring them or anything, but what they did give me was a full CPU for the $5 and fast internet and a couple of regions. So it was really, I thought it's really nice to use this one in this case. Actually, just to give you an idea, if you're in the wrong region, it can be like 200 milliseconds slower than if you're right next to it. So remember the thing with the cables for the trading. Actually, with the cryptocurrencies, now it's just already really good if you're in a similar data center in the same region. You get really fantastic speed gain, and it's also really nice actually to see how fast you get these. I was amazed how fast things can be actually when you're in the right region. Yeah, so here's my fantastically drawn technical architecture. Yeah, so the idea is you have a couple of workers, and you would have a coordination layer, and then you would make a like the first one to pick up the news sends it to the coordination, and then you go to the exchange. And but then I came up with something even better. Like, wow. It's what is nice here is that I have a fire and forget kind of architecture, no need of state. So pretty much I just have like 4 of those cheapest machines. I only care about the internet, but there's still like a lot of like relatively a lot of fluctuation simply in who's going to get it when. And so, you know, like if this is, let's say, like 100 milliseconds or something, which is quite spectacularly high, if you have multiple workers, then it just kind of, well, almost just divides that time. So what are they doing? They're all just saying, okay, I got the signal, buy it. And on the side of the exchange, they will be the ones to say, yeah, that worked, and to the others they will say it doesn't work. It's really nice because I don't need to do any kind of coordination between them. They can all work on their on themselves. They can all be trying to be the fastest. Another really cool thing about that is that let's say I have 3 workers. I make some changes in the code and I want to test it. If I would now do it on all the machines, and I think, yeah, great, I have my monitoring, I go away, and then things immediately, or things break. Then you have like everything down, nothing is happening. But what I found is that this makes it really easy to just have 3 machines working, just add 1 machine next to it with the updated code. And so you always have a base of 3 that are working, and the 4th you can see if there's any issues. The moment you're comfortable, it was running for a couple, like 1-2 days successfully, then you can put that code on the other machines. It was a really interesting way. Of course, this is not comparable to a lot of situations, but yeah, for me it was a fun new kind of way of dealing with this. And yeah, you can also imagine without coordination, without like extra processes, it becomes a lot simpler, and it actually also becomes faster because you have less communication in between. Well, now to the next part. I also never thought I would enjoy Asyncio. So, yeah, the challenge is doing multiple things at the same time. I want to follow multiple websites, and yeah, the thing is that if you are interested in CPU, then you should use multiple processes, especially in Python. And if you're interested in I/O, which is actually the main thing that I'm doing, you can use threads or Asyncio. Well, I never really liked threads, so I thought, you know, okay, fine. I have a project I'm excited about. I'm going to go for Asyncio. And a bonus with Asyncio is there's no need for logging. So it's like once you get how Asyncio, like how async stuff in Python works, it's actually it gave me a lot of comfort in a way. Well, I tried Asyncio when it was 3.3, we had some older syntax, and yeah, the experience was pretty bad. I also didn't go that much in depth. I just tried to copy and paste code, and you know, like before I knew it, I just a lot of bugs, errors, things unexpected happening. But by the point of 3.6, that's actually when I started with the crypto stuff. Was that it was quite an okay experience actually. So there are really nice things implemented, and we'll have a look at some of those things. And I also wanted to mention that the 3.7 version, there's also a nice talk about it. On you can find it from EuroPython on the new things of async I/O. And well, for me then the distinction became really clear that, or they helped with an abstraction for people that are just using async I/O versus people that need more finer grade control, so the library creators. Yeah, I also had this like fun thing is that you can use this kind of project UV loop implemented on Python. And just to give an idea, I don't know really how readable it is, but on the most right side you see Go, and the one next to it is the one on UV loop. So when we're talking about network, actually we're competitive with Python with you know, with this kind of workload on how many requests per second you can do, and that's mostly it's mostly on that. I also experimented with it before I looked up this graph, where I was surprised I couldn't get speed up with Go over what I was doing. So yeah, I tried NIM, I tried C++, and it just I guess it's obvious to some people already, but yeah, I just wanted to see if that would make a difference. But yeah, we're safe here in Python. And actually, I also, when I looked on GitHub, like what kind of libraries are there for exchanges, you would see that like Python is really the language that is being used. If we're talking about implementing a strategy, you can most likely get it done faster in Python than in like those faster languages. Of course, it depends on your strategy. There's of course a lot of need still for faster programming languages. But if you look at what is out there right now, it's still a lot of people doing this stuff with Python. Yeah, so I wanted to give a bit of this is also a talk I've seen by Mr. Smith, not Agent Smith. Yeah, he created a library called Trio, also focused on async. And yeah, so the Python async stuff is a bit different than what most people expect. If you look on the left, you can see the preemptive concurrency, which is implemented, I think, in Java or Go, where things can actually run at the same time. Well, we have in Python, we have the global interpreter lock, which prevents things actually from running at the same time. So the reality is that if you look on the right, that's the way Python implements it. Is you have to specifically mark where you're giving away control, so when something else can run. So the problem with JavaScript, or this can sometimes be very difficult to follow, like what's going to happen when. And with Python, the code, like the for loops with JavaScript, is just confusing to the first moment. But once you get the syntax, this will read like just much simpler code. And because we have the global interpreter lock, we cannot use the left model. We use this model. It's easy, and yeah, there's certainly some beauty in how it's the async stuff is implemented in Python. Okay, well, async code can only be called by other async functions, and that gets pretty annoying. Yeah, what I want to do is actually, you should watch this talk if you're interested in async stuff. For me, it really helped me understand it. So yeah. Yeah, the idea is that they're only being called by async functions. It's running on an event loop, and there's going to be a time where we don't really even have to explain what an event loop is. But yeah, it's more like it's a different model underneath on which functions are getting a chance to be run than without an event loop. But what I thought is that it's going to be fun to do some live coding. So let's see how that goes. I hope it's readable by now. So, all right. So let's go back to the cryptocurrency thing. The first thing you want to know is the price of the current price of a cryptocurrency, and well, let's see. If you let's see. don't know how many of you are familiar with.
Maybe I will take your microphone. Okay.
Yeah. Oh wow, thanks. So yeah, so the AIO-ACP is kind of like the requests library. So you can make requests to endpoints. We see here the where we're going to get pricing information. And here you can see the first time we are having an asynchronous function. And basically what we want to do is for like this Ethereum Bitcoin pair, we want to get the value for that. And it starts with creating a session like with requests. And yeah, you use asynchronous context manager, and again for getting the result. And then here, this is the special line where it says the await. The await means basically like in this line you can expect it to run other code, right? So anytime it's not like that, so on the moment of like this printing, or if I would do like through, like if I would do something like this, then you know, it's like it's never going to go. It's never going to be stopping anymore, because you know now we have it keeps going. Like it will never be stopping it, because this moment we're having synchronous code. So the moment there's synchronous code, it cannot give control to anything. Nothing else can run at the same time. So only the lines where you have like await is a moment where it can switch. So well, let's do it without the while loop. So now we make one request, and this is kind of the result that you get from the exchange. You can, well, most interestingly is that, yeah, this is symbol, and the last price was this. So that's kind of the price for Ethereum combined with Bitcoin. But yeah, this is of course like, there's nothing special here. It could have been synchronous code. But the moment we want to, well, let's do another one. We have to add something because we want to run. Oh. So now, as you saw, it was pretty much done in the same time. And yeah, it was very simple to get this done. Like to do both calls at the same time. Well, in the end, we want to have this globally available. So let's assign it. Like, so we're using a global thing here, but that doesn't matter for now. We can do now this. And you can see now it stores it in this stickers object. Of course, you can make a class out of this in the end. But basically, we could have this. We can still have this in a loop. If we would make this a normal sleep, then again it will just, everything will stop for 1 second, you know, because it's sleeping here, everything is asleep. But because we have here an async sleep, other things can run. Currently, we don't really have anything else, but like now, pretty much it's constantly updating this dictionary. Oh. Well, the thing is that yeah, we can get multiple, right? We can get even more. In the end, maybe we want to even follow 200 currencies at the same time, so that the moment we get a signal about any kind of them, and we think, yeah, this is what we want to do, then you want to buy. So, but for that you have WebSockets, and like, I don't know how many of you are familiar with WebSockets, but it's it's a way where a server can also send you data. So when you do a HTTP request, you're saying, okay, I want this information, and you immediately get it back. With a WebSocket, it's like, okay, let's start communicating. And if you want to give me some information, you can do it. Pretty much with these prices, we just want, anytime there's any kind of change in the price, we want to be knowing something about it. And the cool thing with this, like, really small bit of code, is that you can get all this kind of a pricing information. Live coding. Okay, well, we got at least something, and then I guess I didn't update the code. Let's not do live debugging. It's only live coding, right? Yeah. So this is well. Let's say this is just a fast way of. Yeah, I wanted to point this line out. Is you can make a very nice interface on this async by using an asynchronous for loop. So pretty much you can say again, here's the await stuff happening. So anytime there's something here happening, it can also do something else. Well, let's. I think we're pretty much on schedule for it. Well, but now, after you would do this kind of WebSocket thing with the prices, you could say, okay, now we are following all those coins, the prices, so we have the pricing information, but that's only one thing, unless you want to do, as you remember, the technical analysis, just bothering with the time, with the price at a time. But we want to do something with, for example, Twitter data. So this is an example of how you can do asynchronous Twitter streaming. Again, using like an asynchronous a stream. I'm just going to run it. Let's see. So now we can see live tweets with either Bitcoin or Ethereum mentioned. And yeah, it's really just a few lines, very simple, as you can see. But yeah, you can imagine that when you combine those, then you are somewhere. And I already have a script for that for now, just so that I don't have to type everything. So let's go over this. I imported the Twitter code from before, right? And I'm using this UV loop that makes it like 2 to 4 times faster. We have to handle the message from the price information. That's this function. So it stores pretty much the latest price for a coin. That's what you need, because then you can say, okay, you know what? Some event happened. We know the price, so we're going to send a price. We're going to buy it. Try to buy it at that price. So pretty much you have actually all the information now that you need to actually do this. Here we have the code of the collecting the information of the WebSocket connection and processing the message, getting the messages. Then you need to implement something. Okay, we get text from Twitter, but what are we going to do with it? In this case, we don't have any logic, so it's pretty much, this would be the worst code, worst trading strategy ever. Whenever someone tweets Bitcoin, you buy Bitcoin, right? That's like not really a good strategy, but it's the simplest example. If you, of course, this should be like very complex logic, and this is something you have to really test and verify on data. Well, in the end, I just have this line here, which is saying using the WebSocket. So the thing is, if you do a HTTP call, it was something like, I think 5 milliseconds, and when I used WebSocket, it's 0.007. Like it's really fast. But yeah, so pretty much you're this much away from actually trading, like actually making trades. Then, obviously, I don't want to like have that now happen live, but yeah. So well, I noticed there was indeed like it crashes here, but pretty much here you have an example of, like here we see all the price changes that were happening. The WebSocket is feeding them to us. And here we have a tweet. And here we then say, okay, I would now buy Bitcoin at a price of, right? So, and if you instead make that into an actual buy, then you've just bought. Similar, you would do a similar strategy for selling again. But yeah, it's actually, you don't really need a lot of code to get creative on strategies, to get interested about what more data can I use. And yeah, it's fascinating to me, and it was a really good reason for me to learn Asyncio, and I'm happy I did. Let me see. Okay, so yeah, all right. So that was the live coding part. First of all, I can take it. Thanks, thank you very much. So first of all, the disclaimer that that you really need here. I didn't give any trading advice. This is really just about that is for me fun. You will lose money. In fact, on one trade I actually lost 20%. Yeah, because I had a too simple strategy. No others were also interested in buying it, so I pretty much said at any price just buy it, and then 10 minutes later it was just dumping it. It's like it was really bad. So yeah, bad things happen, as you heard already, by losing the coins, by all these kind of. I didn't even bring up the examples of scams that are being done. There's so many things in this unregulated field that make it a bad idea to actually do it. But for a project, it's interesting, and like when you have actually your own money on the line, yeah, this kind of pressure taught me some really nice tricks. Yeah, I also learned that Python's async implementation is actually much better than you think, and yeah, it's a really nice approach. It does mean that once you go async in your code, you pretty much want to do the whole thing with async, but I think that, yeah, it more and more makes sense to do this. Yeah, that's now it is a better time than ever to actually get excited about async I/O. I think with this 3.7, yeah, it's really a nice way, yeah, to do the async coding. So yeah, that was my talk. Thank you for going through it, and if there's any questions, yeah, you could ask them.
So how do you analyze the tweets?
Well, what you could do is indeed like use, well, so essentially what you're going to do if you want a really simple strategy is to look for the keywords that are associated with the change, right? So for one of the clear examples would be, if Microsoft and partnership is mentioned in an official tweet of like the IOTA guys, well, then we can be sure that the price will go up. Of course, yeah, the analysis to that's the whole data science part of, setting up a way to do back testing. Should you look for hourly changes? Should you look for 24 hours? Like this is the data science part, which is an interesting exploration, but yeah, that's yeah. And then you try to learn that. Of course, there's the automated approaches. So you could also use the machine learning techniques like neural networks for understanding language, or simpler techniques like n-gram. But I did not want, I personally didn't believe that I could build something that is going to be robust in reality using like machine learning. I've more felt like if I do the analysis up front and use that information to make a very simple, that cannot go wrong, right? Like if you do like neural network and you can make it very complicated. I just wanted to have the simplest implementation and do the smart analysis around it.
Hi. There is a risk in keeping money on the market. So have you thought about some kind of analytics service to, let's say, to detect maybe theft or scam or pump and dumps before you, so you can leave the market before it happens?
Yeah, it's indeed a good question. So in my analysis, I pretty much estimated that I would just assume, like the price is going down. So I had the idea, like the price is just going regularly down. Of course, they're going to be really up and going really down. That's you can consider that just simply a strategy, right? Like trying to predict those kind of things. But that's not the approach I chose. Because I had the idea, if I can really get those big signals, which are 400%, if you get it every now and then it should, like I estimated that it's just going to be stronger than the effects of those smaller, downfalls, or like, that was kind of where I went with it. And to the respect of, your money being on the exchange and exchanges disappearing. So another one for the, watch out for the unregularized stuff. They get hacked, money gets lost. Yeah, I mean, that's something I know, and the risk is out there. So yeah, you always should have an exit strategy. Like if this happens, then I go. But yeah, that's a tough one. Yeah.
We have time for one more question. So who was first? I think.
Thank you. Thanks for the interesting talk. I have a question about library you're using, Quart. Did you compare it with the others? For instance, Sanic or some other?
Well, I followed Sanic and the Vibora, and I have seen like the things. But the thing is that with what I'm using, it's more of a debugging process. So it's not about, like, I don't need to do any web server. I just included it because it allows me, for example, to ask the question, when was this URL that I'm interested in, when was it last time accessed? It's just easy to add it for debugging, but there's nothing vital in the application about choosing a specific framework. Also AO HTTP as a server. So there, yeah, could have also went with that, but I already had some Quart code lying around, so it was just easy to say, give information on this particular aspect just for debugging.
Thank you.